The optimists say that, well, the oil is gone, and we don't see it in the water column anymore. And then it turns up in a bottom layer. And some of the folks before this bottom layer was discovered say, well, the bacteria have worked exceptionally fast. It's just gone. We still don't really know. We don't know what the condition of that settled layer is. Is it largely degraded? Is it toxic? Are all the lightweight components out of it, the things that could likely be toxic? We don't know.
So there was that immediate oil hitting the shore, but a lot of that oil that's on the surface is now gone. Gone where? It's a really good question. But part of the answer is that some of it is still out there in the environment. It's lying on the bottom. And it's lying on the bottom close to coastlines. And so even though this initial surface oil has disappeared, we might think that the initial exposure has disappeared. But what's really important to keep in mind is that future storm events are going to resuspend some of that oil back into the water column and re-expose some beaches and some marsh habitats. And any critters that are burrowing down into that sand or burrowing down into the sediment of marshes where some of this oil is stored are going to be continuously exposed over a long period of time.
Speaking and hearing about some of the scientists who worked with the Exxon Valdez in Alaska, especially with their herring problem, and what the situation there was, this species was a commercial species doing fairly well. Right after the oil spill, a cohort came back. The next 3 or 4 years, everything seemed fine. But then later on, they stopped showing up, and then the problem started 4 or 5 years after the situation. And that's what we might be looking at here. We're not going to see an extirpation like we saw in Alaska. It's a different system altogether. But we have commercial species that have probably been impacted at the larval stage. They are not going to be around here in 4 or 5 years. We need to realize that. We need to kind of point out ways to mitigate that and long-term effects. And again, people say oil out of sight, out of mind. This is something that's going to be long-term, unfortunately, here in Mississippi and in southeast Louisiana.
You know, when you look at the ocean and you look at the obvious products that come from it, you see great big fish, and you see great big lobsters and big crabs and big shrimps, and that's what you see in the market. But there's an awful lot of background to this that you must understand in terms of how that gets there. How does it grow up? Where does it reproduce? What does it feed upon? What kind of habitat does it live in? They have these life histories that utilize all these different levels, and so they exemplify that it's all interconnected. You can't talk about that fish unless you're talking about the algae on the bottom in terms of, is there a good environment in which that fish can grow up in?
Well, I'm studying the diversity of the marine algae or the seaweed. So what I'm interested in is looking at what's out there in the Gulf of Mexico. And also now with that oil spill is how the oil spill could have affected the number of species and the quality of the species that was there before. So what is so important about the organisms I'm studying is for the whole ecosystem of the Gulf, for the vitality of the Gulf, is that they are the primary producers, meaning they are the ones that produce the oxygen. And we all know if there is no oxygen, the whole rest of the ecosystem is going to go berserk, basically. So that's why it's so important to have the algae that are healthy and not being affected by negative effects of the oil, etc., to really make sure that they can produce the oxygen and that the rest of the Gulf stays healthy.
But a lot of our questions about whether or not this is going to create a hypoxic or an anoxic zone in the Gulf of Mexico and beyond hinges on how much oil originally came out, how fast is it moving and mixing with the water mass and with other sources of carbon, and how long is it taking for that oil to biodegrade. In terms of landed oil, again, one of the fascinating things that we've noticed through our sampling is that the sampling is, or where oil is washing up, is very spatially heterogeneous. That's a fancy way of saying it's splotchy. You can be in one marsh and you can find oil up to your ankles, literally, and you can go a few miles away and not find a trace of the oil. So it's interesting how it's been transported from fairly far offshore into these sensitive ecosystems, and how natural currents and wind patterns have coordinated into certain areas and kept other areas relatively oil clean.
So it seems like the event is over, and it's over for a lot of people that make their living here. But they make their living on the organisms that live in a lot of these marshes, or at least the ecosystem health is what supports a lot of this economy. And the effects on ecosystem health I don't think we've seen those yet. Those haven't emerged yet.
The fears that folks have about will I see those communities come back that I've grown to depend upon being there, whether I simply go to the restaurant to eat them or whether I'm out there as a scuba diver or a fisherman enjoying that community for a variety of other reasons, will those be there again? I think we're going to be able to shed some light on that very soon.